All right, Algebra 1B students, welcome to part 1 of lesson 7-8, which is about geometric sequences. We are going to be on page 467 for today. We're just going to be looking at what a geometric sequence is, and then next week we will deal with their formulas and how we can use them in interesting ways. But for today, we're just going to worry about what a geometric sequence is. And it's all based on these exponential expressions that we have been talking about for the past few videos. So just as a reminder, our exponential equations should all look like that. Y equals some number a times some number b to the x power. All right? And remember that a is our initial amount, and that b is called our growth factor, okay, or our decay factor, depending on if it's bigger than or less than 1. Now, if we put in x values into this equation repeatedly, say 1, 2, 3, 4, and so on, the list of our y values that should come out would be this, right here. This is our list of y values. A times b to the first power would be a y value if x equals 1. A times b to the second power would be our y value if x equals 2. A times b to the third power if x equals 3. A times b to the fourth power if x equals 4, and so on. So all of these things are y values. Right? Y value, y value, y value, y value. Just as an example, if we look with some concrete numbers here, if we start with 2 and multiply by 3 over and over and over again, our equation would be y equals 2, that's our starting value, right? Starting value, times 3, that's our growth factor, to the x power. And our y values list would be right here. If x was 0, 3 to the 0 power is 1, 2 times 1 is 2. If we multiply that by 3, we get 6. That would be if x equals 1. If we multiply by 3 again, meaning x equals 2, we get 18. 6 times 3 is 18. And finally, if x equals 3, we would get 18 times 3 again, which gives us 54. Okay, so there's 4 y values for x equals 0, 1, 2, and 3. Okay? This list right here, this list of our y values, is an example of a geometric sequence. All right, now here's something that I definitely want to see in your notes. The definition of a geometric sequence. Okay, so a geometric sequence is here. A sequence of numbers where the ratio of any term to the one before it is always the same. All right, we'll talk about what that means in a minute. But pause the video, add that definition to your notes, and then come back and we'll talk about our example. Okay? Now, if we look again at our list of y values, 2, 6, 18, 54, and we try to interpret this definition in the context of this example, let's look at what it says. It says the ratio of any term to the one before it should always be the same. So I'm going to start out here with 54, and I'm going to look at 54 and the term before it, which is 18. If I make those into a ratio, 54 over 18, this is really a division problem, and I can do 54 divided by 18, and I should get 3, or 3 over 1. Okay, because I divide both by 18, and I get 3 over 1. Now I'm going to do the same thing again, but I'm going to look at 18 and the term before that one, which is 6. If I do 18 over 6, 18 divided by 6, hopefully we know that's also 3 over 1 if I divide top and bottom by 6. Okay, and one more time, I'm going to look at 6 and 2. 6 and 2, because 2 comes right before 6. So if I have 6 over 2, that also equals 3, or 3 over 1. Okay, so what I want you to notice is every time I looked at a term and the number before it, and I divided them, I got 3, 3, and 3. This should make sense to us because what number did we say we were multiplying by over and over and over again? 3, right? So the number that we continually multiply by, or our growth factor right there, is what we should get anytime we take a number and we divide it by the one before it. 54 divided by 18. 18 divided by 6. 6 divided by 2. Now, looking at it a different way, if you prefer this method, that's fine. Going from one term to the next, we should also be able to see a pattern there, right? To go from 2 to 6, 6 to 18, and 18 to 54. Now, instead of dividing backwards, I need to get bigger. So my question is, what number do I need to multiply by to go from 2 to 6? Hopefully we can see that's times 3. Okay. 6 up to 18, again I'm timesing by 3. 18 up to 54, again I'm timesing by 3. Okay, so a geometric sequence is one where you should times by the same number over and over and over and over again to get the next value in your sequence. All right, so two ways to look at it. We can either divide by the one before it and see that it's the same number, or see the pattern of multiplying continually by the same number over and over and over again. All right? So your job then is to decide, is this a geometric sequence or not? Starting here with number 1. If I look at, I will do the division method on this one. If I look at this big number way out here, 20,000, and I divide that number by 2,000, 20,000 divided by 2,000, that just equals 10, or 10 over 1. Right? And if I do it again with 2,000 divided by 200, 2,000 divided by 200, again, that equals 10. And one more time, 200 divided by 20 also equals 10, right? So is this a geometric sequence? Yes. Yes, it is. Now let's try that same method with number 2. If I look at the last number and divide by the one before it, 10 divided by 8, 10 divided by 8 equals 1 1/4, 1.25 if you do that on a calculator. Let's see if that matches up with 8 divided by 6. 8 divided by 6, do that on the calculator as well. And we should get 1.33. So I have an issue here because the number I got when I divided doesn't match up when I go from term to term. Right? And we can also see that if I go with my multiplying method, to get to 4, I should times by 2. But 4 times 2 should get me to 8, not 6. Right? So this one, no. No, that is not a geometric sequence. Right? Now, number 3 is probably the weirdest looking one. It's just the same number over and over and over again, except I flip from positive to negative to positive to negative to positive. The question I want you to ask yourself is, what number can you multiply to make something go from negative to positive to positive to negative to positive and so on? Right? And hopefully you know that that's a negative 1. If you don't, you can use your division method here and do 5 divided by negative 5, that's negative 1. Negative 5 divided by 5 is negative 1, and so on and so on. Or if we look forward, To get from 5 to negative 5, I can multiply by a negative 1. To go from negative 5 back to 5, I can times by a negative 1 again. And so on, and so on, and so on. So to flip from negative to positive with the same number, that answer is most definitely yes. That is a geometric sequence. Right? Now, your only job before class on Monday is to take a look at these 3 sequences and decide, are they geometric? Are they not geometric? Yes or no. Simple yes or no will do there. And then when you get back Monday, we will do some practice problems about identifying geometric sequences. That's all I have for now. Have a wonderful weekend.